Hi everyone, in this video we're going to explore wireless image transmission using a PlutoSDR device, building upon our previous video about wireless message transmission. Images are fundamentally composed of binary bits organized in the 3D matrix representing RGB color channels. The resolution of an image determines the number of the pixels and consequently the amount of data required to store and transmit it. Transmitting a full-color image wirelessly presents significant challenges due to the massive amount of data involved. To manage this complexity, we'll take a systematic approach. We'll start by transmitting low-resolution black and white images on the left side, and we'll progressively increase image complexity and resolution. We will demonstrate the principles of wireless image communication step by step. This kind of approach allows us to understand the core concepts of image transmission while managing the technical challenges of data transfer over a wireless channel. Now let's see how it works. Here I have downloaded the black and white images whose pixels are composed of only 1 and 0 bits. We will convert this image into a binary array, as you can see here, and then transforming the visual data into a digital format that can be transmitted wirelessly. This process involves converting each pixel's black or white state into binary values. So for the 1, it's representing the white, and 0 for the black, and flattening the 2D image matrix into a 1D array of binary data, and preparing the binary sequence for wireless transmission. We will apply the same modulation technique from our previous video to ensure accurate data transmission and reception. Our goal is to verify if the SDR device can correctly restore the original image data at the receiver end. Let's see how the receiver correctly receives the data. After I press the run, here we have a received image that is correctly restored. So in the low resolution case, it is working very smoothly. So we can go to the next step, the higher resolution image. Here is our higher resolution image, maintaining the same shape as our previous lower resolution version. As you can observe, the image has now expanded to the 100 by 100 pixel matrix, which means we now have 10,000 individual bits that need to be transmitted. This significant increase in data points raises an important question. Will our previous transmission method still work smoothly? So let's see how it works. So here is our final image. As you can see from the final image, it has a lot of errors in the image, and the bit error rate is about 0.5. The reason why it happened is because of the CFO, or also known as carrier frequency offset. As we send very large amount of bits, it has some delays that causes mismatches when we do the channel correction. As you can see from the IQ constellation, you see the circular shape here due to the CFO. Here's one fun fact, by the way. This time, let's connect the physical wire on the PlutoSDR device and let's see how it works. Now, let's look at the difference in performance between a wired and a wireless connection in our SDR system, specifically focusing on bit error rate. In a wired setup, the transmitter and receiver are directly connected by a physical wire, like your Ethernet port on your desktop. This provides a clean and stable signal path, free from external interference. Here are the key advantages. There's no channel impairments. The signal doesn't encounter noise, fading, or Doppler shift like in a wireless environment. And there's a high signal to noise ratio. And also there's a minimal distortion and no interference. Now, let's contrast this with the wireless setup. As you can see the image here, the image is very clear and there's no error even though we are sending about 10,000 bits. That's the reason why we're using the wired connection for the Ethernet port for the stable connection. You might have any experience that while you're using a cell phone, your internet may experience some kinds of lagging or the speed slow down. That's because there's a lot of factors that might affect the speed and the quality of the wireless communication. Thankfully, there is one effective way to compensate for the errors we see in the wireless communication. It's by using OFDM, or known as orthogonal frequency division multiplexing. Let me very briefly explain how it works. The OFDM splits the data into smaller substreams and transmits them over the multiple orthogonal subcarriers simultaneously. So each subcarrier operates at a lower data rate, which makes it more robust to error caused by multipath fading or interference. So unlike the generic case that the data are sent by the timely manner, we're sending the bits in the different subcarriers in the frequency domain. So in a conclusion, we have successfully transmitted a low-resolution image file wirelessly using the SDR. But the challenges we have encountered is that the significant errors when transmitting high-resolution image files wirelessly. And we successfully analyzed the errors and identified the need for the robust techniques like OFDM or error correction to mitigate high BER. And key takeaway is that wireless systems require advanced techniques for reliable transmission of large data, emphasizing the balance between the data rate and error resilience. So the next thing we're gonna do is to send the color image, unlike the black and white image we just sent today. So we have covered how the color image works briefly today, and it's gonna be more challenging and more interesting. Until then, I hope you all have a great day, and I hope you enjoyed my video. Thank you.